Sample problem 5.4 is an example of Avogadro's law, using Avogadro's law. It relates volume to the amount, or in other words, to the moles, right? Because anytime we talk about the amount of these chemicals that we've been talking about, we use the unit of mole. So that's Avogadro's law. So let me read the problem and then I'll talk to you more about that. It says a scale model of a blimp rises when it is filled with helium to a volume of 55 cubic decimeters. When 1.10 moles of helium is added to the blimp, the volume is 26.2 cubic decimeters. How many more grams of helium must be added to make it rise? Assume constant temperature and pressure. All right, so let's see. I'm going to show you what we essentially gained from Avogadro's law if you read about it in the textbook. And it relates volume to the number of moles. And it is V1 over N1 is equal to V2 over N2. All right, now V is volume, right? So I've got the first volume and the second volume. N is the number of moles, N1, N2. So I change the volume, or I change the number of moles, the volume changes. They're directly related to each other. All right, so let's see how we can use that to our advantage. They're changing the volume. You can see here we're going from 55 decimeters. We're filling it to 55 decimeters with helium, and it's starting out at 26.2 cubic decimeters. And they've got 1.1 moles of helium in that. And they want to know how many more grams of helium must be added to make it rise. And so it needs to get to this 55 cubic decimeters. Now, again, they're asking for grams, and they're giving us information about moles, so obviously we'll use molar mass as our conversion factor. You'll remember that that's the conversion factor that relates grams to moles. So I'm going to use Avogadro's law here to figure out the moles. All right, so let's see. This N2, that's what I'm going to be solving for, right? I need to know what my new moles are, so I'm going to say N2 is equal to, I'm going to do some algebra here. So let's see. I'm going to have V2 N1 divided by V1. Right? That's how I do this algebra. I had to get this guy by itself, and I needed him up top. So I multiply both sides by N2 first. So that put N2 over here. That means I needed to divide by V1, so that put it in the bottom. And I needed to multiply by N1, so that put it in the top to get this N2 by itself. So that's my algebra, and you can work that out for yourself to prove it, to yourself if you don't feel comfortable with my explanation there. But anyways, okay, so now let's start plugging things in. So N2 is going to equal V2. That's the volume we're changing to, right? We're changing to 55 cubic decimeters. I'm starting out with 1.10 moles of helium. And then my first volume that I'm starting out with is 26.2 cubic decimeters. All right, so cubic decimeters divided by cubic decimeters cancels, so I'm going to be left in moles of helium. So let's see what I've got. 55 times 1.1 divided by 26.2. All right, and so I got 2.31 moles of helium. All right, so it's asking for how many more grams of helium must be added to make it rise. So we already started out with 1.1 moles, so I know what my new number of moles is going to be now, right? It's going to be the 2.31 moles of helium. So to figure out how many more I have to add, I just subtract, right? I've got my 2.31 moles of helium. That's N2, and I already had 1.10 moles of helium in there, right? That was my N1. So my new is going to be 0.21 moles. I'm sorry, not 0.21, 1.21 moles of helium. And now I can convert that to grams, right, because they're asking about the grams, by using the molar mass of helium. And so in 1 mole of helium, and this is directly from the periodic table, right, there's 4.003 grams of helium. And then 1.21 times 4.003 is then going to equal about 4.84 grams of helium. So that's how much more we're going to have to add to get this blimp to rise.